Jack and Abdullah are going to talk about securing containers on the high seas. I'm going to just stop talking so they can get going. You guys have fun. Give them a big hand.
Hello, everybody. Quick show of hands, who works with containers? Wow, that's actually a lot. Who works with orchestration? A little bit less. Okay, all right, cool. Go ahead.
Cool. So today we're going to talk about how to secure containers pretty much from developer's desktop through production environment. So we're going to focus on essentially design, building, shipping, and running our containers in production. So we're going to take a look at the security controls we need along the way beyond what we're going to do inside the container runtime.
All right, so we came up with this idea for this presentation based upon a bunch of conversations we had with a bunch of different organizations that kind of had the exact same question. How can we develop an enterprise container strategy that implements security throughout the container lifecycle? So this presentation will focus, it will cover container basics, and then we will move along to discussing each phase of the container lifecycle.
So with regards to the life cycle, we have design, building, shipping, and running. So at the design phase, we can actually think about things, model out how we're going to build our architecture. Things like isolation, network segmentation, propagation of secrets, access control, as well as things like hardening the containers. We have to think about how that propagates throughout our architecture. We're building things. We have the opportunity to harden things at the container level. When we ship, we want to make sure we can integrate securely with the environment. And when we get the runtime environment, we have the ability, again, to mutate container state and do security, as well as do runtime enforcement of policies.
So what are containers? So containers are small, they're lightweight, sole-purposed, and they have sandboxed application processes. The other thing is containers are amazing for those of you who are running microservices. So let's talk a little bit about container architecture. So architecturally, we have the components within this diagram. So up on the top left, we have our version control. We have our container registry, our CI/CD pipeline, the control plane, as well as the cluster of containers that you'd inevitably push to production. Some of the things we want to pay attention to, making sure that we have proper access controls on those components. We also want to focus on making sure that those components are isolated and that between those two dashed lines that we have access controls within those trust boundaries. So security opportunities and optimism. So there's a lot to be optimistic about with containers, right? We have a reduced attack surface that's based upon a single purpose, small footprint container. Containers are immutable. They're isolated by design. And because of the small footprint, the sole purpose objective, things like automation and repeatability are comparatively easier to implement. However, while there's optimism, there are still some challenges within your organization that you're going to face. Basically, containers do not equal security. So if you are running an extremely vulnerable and old struts application in your traditional infrastructure and you migrate it to a container, it's still a vulnerable version of struts, and that's not going to fix anything. The other thing is that you want to take a look at, you're introducing a full brand new stack. And that stack has got multiple components, tools, third-party plugins at various levels. Those components themselves could be vulnerable. So managing any patches, updates, anything like that, that's a full-time job for probably more than one person. So then the question becomes, who owns it within your organization? Is it IT? Is it development, infrastructure? Who is it? Are you going to train individuals internally within the organization, or are you going to go and hire people from outside? Those are definitely things that you want to consider while you're taking a look at the strategy. Jack's going to talk, well, we're going to move right into the life cycle phases, and Jack's going to start with design.
All right. So talking about design. So if we look at our containers, they're really dumb, right? So we build a lot of things around them, like service discovery and routing. So the containers themselves are pretty unaware of how they're actually going to run as a workload in production, right? So there's a lot of scaffolding we build around the containers, and we don't necessarily build that intelligence into them. So things you want to understand are how are those containers going to interact with other services? How tightly do you couple components, right? So generally we're building microservices is our pattern with containers, right? So we want to be careful about, just from a development and the ability to iterate and pivot, we don't want to tightly couple components too tightly. So meaning we want to basically avoid shared credentials, things like that. We want to understand pretty much how those services are going to be able to abuse each other, right? So key exchanges, the whole 9 yards. So some of the things we focus on, so once that container moves upstream, it's probably running in some orchestration platform. So we need to think about things like our control plane, right? So who runs like Kubernetes, runs their own control plane without a managed service? Can you talk to like the API server from your desktop, or do you have that isolated wall? Good. There may or may not be some organizations that everybody can maybe talk straight to the API server, right? So really, really bad. You definitely have a lot you have to do in the control plane to harden things. Network segmentation and isolation. So this is a religious thing too, right? How much do we do micro-segmentation versus how do we use something like an Envoy, maybe like a sidecar or a proxy to basically offload that from the container. Considerations, how much of the controls we build into the containers versus how much do we build into the infrastructure around it. So things like encrypted communications, a lot of times it's pretty flat and wide open. You can use different tools now to put wrappers around things so you don't have to worry about doing TLS from the container itself. Authentication, so we think about how does it interact with other services? How does that container interact with the cluster itself? So if you're using Mesos, Kubernetes, then you're familiar that your accounts are going to run with, so your services will run with a service account, right? And you have credentials for that. And potentially you can use that service account and the credentials to do stuff at the cluster level, potentially elevate privileges, move laterally. So you really want to think about what kind of rights does that container run with, and do you share those credentials across services? Identity management, so you're going to give your developers and a lot of different people access to API potentially. Do you allow them to pull secrets for any application? So if you have a bunch of applications in a single namespace and one person can pull credentials for all of those, maybe they don't have any reason to pull them for the other apps. Maybe you break things like separation of concerns. So you want to think about those access patterns and how you can get to those things. And we'll talk quite a bit about secrets management. You shouldn't hardcode things into Docker, and you could either do secrets management the easy way, or you can do dynamic key rotation and things like that, which is definitely a recommended way to go. With regards to runtime, so everybody's like, hey, Docker, but fortunately there is life after Docker. So here's an example of a few. Me personally, I've worked most with LXC and Docker at this point. But there's some other containers out there now. Has anybody heard of Kata containers? So you're starting to see containers are starting to try to go hypervisor mode. So traditionally, tools like Docker have used Linux namespaces and control groups, shared kernel, and so there's always increased likelihood of a container escape at that point. When we go to a hypervisor, we're obviously limited that surface for escape just a little bit. And as you can see, some of the containers, Rockets had that for a little bit. And you see LXC and Docker going there at some point, and you're starting to see more containers now introduced like hypervisors. There's additional things, for example, if we look, each container runtime kind of comes with different things by default. If you look at Docker, they kick ass with regards to things like their defaults for AppArmor, their seccomp and everything like that. So honestly, you can use out of the box, as long as you enable some of these things in kernel, you can get some inherent protections pretty easily. But definitely depending on the container runtime, you're going to get a little bit more or a little bit less. And additionally, we can also solve some things pretty easily by good design, right? So in this example, let me pull out my trusty little pointer here. So essentially this here is one of our services running in a container, and here's another service running in a container. So what we end up doing is we put an Envoy proxy. Does anybody use Envoy in their environment, or Istio or anything like that? Super cool. Essentially Envoy is like an L2, L3 proxy, and so you can put that in front of your service as such. And so what this will end up handling for you, it'll do TLS, so it'll handle encrypted communications between services. You can also basically do access control. So in this example here, if you look at, we have a namespace and we have a service account. So what it's using to do access to other services, it's using that underlying service account, and then that's basically being authenticated across boundaries. So this kind of gets into a religious debate. Do you do like tons of like micro-segmentation, or do you basically use like PKI infrastructure and certificates to do that? Me personally, I kind of like offloading some of this stuff and let the containers be dumb and light. But just this is an example of how you can solve many, many security problems in one swath by good design. Service meshes, people call them service mesh, is kind of the nickname for that. But the service mesh is a pretty popular pattern with containers and cloud-native systems.
All right, so on to the build phase. So the build phase is, it focuses on basically everything from development all the way up to being ready to deploy your application. So base image management. So you want to make your image as small and as sole purposed as possible. You want to limit that attack surface. We strongly recommend you use as bare bone and stripped down of a Linux kernel as possible. So we highly recommend leveraging Alpine Linux. Does anybody know, is familiar with Alpine Linux? Yes? You can pull down Alpine Linux. It's a really good start for you. When you, within your container registry, when you are essentially pushing up images, you want to make sure you specify version tags, and you don't want to use image latest. I think everybody can see the problem with image latest where you don't know which latest is latest. The other thing that you want to do is leverage the built-in Linux kernel security modules. So seccomp, AppArmor, and SE Linux are really great places to start. Now, if you don't have an internal container registry, you don't have the capability to do that. If you go and pull down containers from external container repositories such as Docker Hub, you can actually run those two commands at the bottom there to be able to determine if that container has seccomp or AppArmor enabled by default. So limiting privileges. So more often than not, your container does not need root. You want to limit the amount of times you need to use root or any sort of elevated privilege. Try and separate the process of building your container versus running your container, because oftentimes you're going to need a higher level of privilege to build it and a lower level to actually run it. The other thing that you want to take a look at, so here's a good example of separating it out is basically the example of the ping command. So the ping command specifically uses the capnet raw subcomponent of root. You do not need full-blown root in order to run ping. So you can simply enable that specific component, capnet raw, and disable the rest of root, and you'll still be able to have ping functioning perfectly fine. So kernel hardening. So you want to restrict the actions that a container can perform. And one of the things you want to leverage, as I touched upon earlier, is leveraging seccomp, which basically restricts the actions that your container can perform. If you would like to try and enable seccomp, but are not comfortable enough to write a policy from scratch, Docker has a really great out-of-the-box seccomp policy. You can take a look at it on the Docker information. It's a really good way to get started with with the seccomp policy. If you take a look at the image on the right, what you're going to see is an example of a basically example of a seccomp policy. So on the bottom, you see that we're explicitly whitelisting syscalls, and in this case, it's bind that we're explicitly whitelisting. If a syscall is not explicitly whitelisted within the seccomp policy, it will not be allowed. Mandatory access control. So, or blank screen.
He's gonna dance now.
What did you do? Come on. Tell me if anything. Oh,
There we go.
I didn't do it. So mandatory access control, just like kernel hardening, is a really important part of the build process, or the build phase, I should say. You can achieve this by leveraging two additional built-in Linux kernel hardening modules in SELinux and in AppArmor. AppArmor basically restricts the capabilities of processes within your container. Within an AppArmor policy, you can specify to block an unauthorized process, or you can also set it to warn, which basically throws an alert and still allows it to go through. Similarly, SELinux focuses on specifying processes and the resources within your kernel that process can access, and that's done based upon a labeling system. So once again, Docker to the rescue, where Docker has a really good default AppArmor profile. So you can enable that profile if you want to get started, but once again, are not too comfortable with writing your own. On the right is an example of a sample AppArmor profile. And so we basically see that it's denying network raw and denying network packet. What that basically means is that it's denying all network traffic. So if you were to go into your container and try and run something like ping, you're going to get an output similar to that, where you got lack of privilege to be able to run that kind of command. So container package management. Within your containers, your vulnerabilities are going to manifest from your configurations, within your packages, and your application's actual libraries. So we remediate this, or we address it, by leveraging a couple tools, Claire, Dependency Check, Brigade, and there are also some commercial tools, but we won't really touch upon those here. Claire is a vulnerability scanner for your containers, and Claire works by basically taking a look at the components within your container and matching them against its own known list of vulnerable components. And if it detects any matches, then it'll throw the alert that you potentially have a vulnerable component running within your container. Dependency check, I hope everybody in this room knows what dependency check is, but for those who don't, dependency check is a OWASP flagship project. It scans your application's third-party libraries to determine if there's any potential vulnerabilities within those third-party libraries. So Brigade. Brigade is an event-based scripting tool that is specific to Kubernetes. So the great thing about Brigade is you can basically use webhooks to hook into GitHub or hook into a couple other resources. So say, for instance, a developer committed code to a GitHub repo. Brigade could trigger an alert based upon that commit event and automatically tell Claire and dependency check to run. Similarly, it can do the same thing with your container, where if it detects that a container has being pushed to an environment, it can pick it up and basically run Claire and dependency check. Similarly, you can also do your security and unit testing the exact same way, where once again, if code's pushed, Brigade can via webhook basically take a look at what was pushed and fire off your unit tests and your security tests as needed. Lastly, Brigade via webhook can push notifications or push the output of the scans to any sort of messaging system that takes webhooks. So for instance, with us internally, we use it, we have a Slack channel. So via webhook, we push the scan results and publish them to a Slack channel so we can see them right away. Next, Jack is going to talk about shipping.
Cool. So here we're going to focus on from the time that we got from our registry, we've done integration things, and now we're getting ready to deploy to the actual environment. So there's a few things we want to think about there. So we want to make sure that we securely move it there. So we need to obviously validate the integrity of the container, validate the publisher, validate that certain things that we expected to happen actually happen before we promoted that container. Additionally, depending on which flavor of orchestration you use, you also have some form of admission controls or validating interface. So I'm a Kubernetes guy, if you couldn't tell, so they use pod security policies. We'll take a look in a minute with that, but you have the ability to pretty much deny admission to the container if it doesn't basically have some security constraints you're looking for, or you can actually mutate that container at runtime before you admit it to the cluster. So here's an example. If anyone's using Docker, Docker Content Trust and Notary can give you the infrastructure to do all this. Certificates, but basically the gist is your containers and different images and tags are going to be signed. So you could potentially have 1.1 that's signed, 1.2 that's not. So basically what ends up happening is that if you would run, like say a Docker run on a specific image and it wasn't signed, then that command's not going to work. And then the other side is, so you can do that, but then you need an ability at the cluster to be able to detect that, right? So Kubernetes has what's called emission controllers. So you can write like an emission controller to do that validation before you basically do the emission. Depending on what system you're using, you're going to approach that maybe a little bit differently. With regards to preconditions, so here's an example in Kubernetes land. We call them pod security policies. So basically, any container that's going to be getting admitted to our cluster is going to have to undergo this. So we'll use things like role-based access control to tie them to certain user groups. And then whenever we emit those containers, so some things can potentially mutate their state, but then we can also deny things. So an example here, first thing is we're forcing things, containers, to use a Docker default and use AppArmor defaults. Obviously, that means you have to have a container that supports that in kernel, right? So it has to be built that way. From here, we're able to do things like limit the container's ability to use underlying resources. So things like IPC, things like network volumes, and so on and so forth. We can limit the volumes here that you can attach to. And additionally, we can also specify that our containers can't run as root, right? So basically, if you try to use a container as root, it's not going to work that way, right? As Abdullah mentioned, more often than not, you don't need root. People overuse root quite a bit. But this gives you a nice inherent centralized control and some assurance that if people are pushing containers, they're pushing containers that are fairly secure. And if they're not, then we're going to make them a little more secure. So that covers emissions. And in theory, if our containers are kind of sort of secure and we've configured them correctly, now we have a container running in production, right? We're about to. So we're going to talk about running here. So this is going to be very Kubernetes heavy, this section. I'm not particularly as competent at Mesos. Here's an example of the Kubernetes control plane, right? So now our container's gone from our developer's desktop, we've pushed it to version control, we've built the container, it's interacted with our CI/CD pipeline, and now we've shipped the container to our cluster, right? So here's an example at a really high, maybe a little bit dumbed down level of Kubernetes. We have masters, and then we have nodes. So on the master and part of the control plane, we have management API, we have etcd, which is our key value store where all the cluster state is. And then we have the scheduler and the controller, which are going to be doing resource allocation, and then controllers. There's going to be controllers for things like secrets, different types of workloads. You name it, there's a controller to do that. But when we look downstream at the nodes themselves, what we notice here is that we have Docker runtime, right? You can essentially swap that out for any container that supports like OCI, but here it's Docker. And basically here we have the kubelet, which is kind of sort of a wrapper around the Docker runtime, which communicates upstream to other control plane components. So basically what we have here is the nodes are going to run our containers. You could have the same container running across multiple nodes, right? So the nodes will spread out things like namespaces, and they'll handle, running those workloads and scaling them depending on what your strategy is for that. The things we're gonna have to focus on though, service and account authentication, obviously control plane hardening, right? So Kubernetes out of the box does some ridiculous things that you wanna harden. Everything's gotten better version by version. So like 1.11's kind of gotten a little bit better with defaults, but if you're on like 1.5, 1.6, you gotta do a lot of like control plane hardening. So with regards to control plane hardening, it really is the keys to the kingdom. I can't stress that enough, right? I've seen Kubernetes APIs deployed with no authentication, no access control, which means if you can talk to that, you pretty much own the world. So you really want to focus on isolating that control plane. Now, if you're using like a managed service, whether that's Mesos on something or Docker or any of the managed Kubernetes services like EKS, Azure's AKS or GKE, they actually manage the control plane for you, and you don't really have any control over that in comparison. So if you're using a managed service, you have a lot less control plane hardening to worry about. If you're running bare metal clusters, like you need to harden that control plane. So management APIs can be a train wreck sometimes. So depending on versions, you can have management APIs with no authentication. So there was an architecture review my team was working on maybe a year ago. And the team is super duper savvy, right? They've done everything in their pipeline, right? They've done everything magical, and they find all the security issues and all that. And really proud of what they did. And then there was one developer in the room who was like, we don't deploy it like that. We just use the API because there's no authentication. They're like, oh, crap. So that's an interesting thing, right? You would expect that your developers or maybe attackers are going to go through the expected flows, and you could just basically push containers if you can talk to API, right? You can kill containers. You can actually run shell commands in containers. The API is a great thing to abuse. With regards to authentication, so whether you're in Kubernetes land, Mesos land, the containers are going to run with service accounts. In Kubernetes, each namespace actually gets a default service account. A lot of times people won't actually use an explicit service account, which means it uses the default, which means all of your containers, potentially in that namespace, could run with shared credentials, which means they'll have equal rights to do things at API land. So one application could stop another one app could run commands in another one app could steal the secrets from another one, so on and so forth. So you really do want to make sure that you limit that account reuse, because you're going to make it a lot easier for attackers to elevate privileges and move laterally throughout your architecture. With regards to roles, so here's an example of how Kubernetes does this. So each one of those service accounts or users is going to have privilege to do things at the cluster level. So in this example here, what we're doing is we're taking an account and we're restricting it to only be able to read pods. So it can do get, watch, and list. It can't do things like delete, update, so on and so forth, right? So it's only basically read events. So we're limiting essentially at that point anyone that's going to be using that role is only going to be able to do those things. So the good thing in Kubernetes is that RBAC is cumulative, so you can't take away things, you can only grant them. And then after we've done that and we've created that role, we have to actually bind that to a subject. So this could be a service account, this could be an API user, but essentially what we've done here is we've limited what that service can. So lots of times you can use service accounts to run services, but developers will also use that to authenticate to the API and dashboard. So service accounts are one of those things that people abuse for different reasons. Logging and monitoring. So in comparison to having the big strut server that I don't know how long it's up and it's big and fat, right? We're essentially killing off containers pretty quick, right? We try to keep them immutable. We're not persisting anything inside of the containers, so we can kill them and we recreate that state from outside of the containers. But at the same time, because we have that shorter life cycle, that data, right, is volatile, right? So we kill that container, we potentially lose logs, we lose visibility into things. So we do want to focus essentially at the application level, the OS level on the container. So you're going to get things like SE and Linux violations and whatnot, container logs for start and stop. The orchestration management, so you're going to get things like API access violations, you're going to get pretty much all the events and things, good and bad, that people have done. And at infrastructure level, so if you're using something like AWS and AKS, there's a few API calls, create cluster and a few of those at the AWS level. And so you can get visibility into things that happen for your containerized architecture at the cloud provider level as well. With regards to secrets management, don't do this. Does anybody do that? If not, put your head down in shame. This is an anti-pattern, right? So we don't really need to hard code credentials into our Docker files. Most of the popular container tech actually have some facility to do this the right way. So don't do this. So if we do it Docker mode, right, the one on the top is using environment variables. I don't recommend that because pretty much any process can read those, and we can't do any restriction. In comparison, if we're using secrets, we can actually restrict access to those volumes where those secrets exist. We can do it in Docker as well, but basically avoid that. This is definitely the way to do it. So use Docker secrets, use Kubernetes secrets, but unfortunately nothing is perfect, right? So those secrets are still stored in plain text inside of etcd. And you can see it there. So Kubernetes, and there's other tech, Docker also has a fairly decent facility to protect secrets at rest. But basically you just cat those out and get them, right? So you can encrypt those. It's symmetric encryption, right? And in theory, if you get onto that master and you're gonna get everything anyway, right? So it feels good that we can encrypt them, but it's not necessarily the greatest control. And if we get onto the master, we're gonna get everything anyway. We can do things like integrate with vaults. Does anybody use vaults? Cool. So Vault works really nicely with Kubernetes and service accounts. So essentially at this point, we're using the service account for the container. That service account then authenticates through Vault with JWT, and then that unlocks the secret. So we're not actually keeping the secret inside of YAML or source code repositories, but rather we're loading that at runtime. So Kubernetes has what's called an init container that runs earlier in the lifecycle, and that can grab that secret and then pass that upstream in the lifecycle. So if you want to do something dynamic, this is a good pattern for sure. With regards to enforcing policies and kind of overriding and collaborating the Docker file, so if you want to have a little bit more assurance, Kubernetes and pick other tech will also allow you to override container runtime stuff. For example, here, you can limit capabilities, the ability to do privesc, right? And regardless of how that Docker container is configured, if you would apply this in Kubernetes added to the container admission, you could pretty much overwrite some of that state. So you can have a configuration-based way of controlling what your developers do. Great. So that's our show today. So in conclusion, we kind of talked a lot about outside the container. We looked at hardening container, but then we looked at how it moved throughout our architecture and how we harden it at multiple layers. You don't need root. You can usually start without root. My advice is if you can just basically block root from day one, get people used to not over-privileging their containers. Certainly focus on isolation, things like network boundaries, accounts. The more we can isolate our processes and keep them from sharing things, the better. Because that means one container is going to get owned, but all the containers aren't going to be owned, right? It's going to be hard to move laterally, and you're going to be basically contained in the container. That's our show, folks. Happy to take questions.
So for the record, it's Abdullah. I know you're trolling me, so.
Might have left it out.
Any questions?
At what point of time the container should be signed in notary?
Silent?
Sign it.
Silent as in? So,
Signing.
Sign it, yeah.
with regards to, so meaning basically, so from developer, are you talking about from developer desktop to registry or registry? And then, I mean, so you can sign things a couple levels, I guess. What specifically, I guess?
I mean, should we sign every image that been pushed into registry, or sign only specific images like that pass through QA, etc.?
Right, so you generally want to do that after, exactly. You've basically passed your tests, you have some checks on security, right? Dependencies are good. Yeah, so then you can basically sign it, and then that's a trusted build. And if somebody tries to pull it, they can. If they haven't signed it, then that means like it's a container you shouldn't pull. So that is a way to prevent people from deploying insecure containers, but you're not going to do it to like latest, right? So that's the wild card. If people pull latest, it's Pandora's box. They get whatever they get at that point.
And I also believe that some of the public container repos as well are starting to do signing as well, right?
Mm-hmm.
I think the Google's is starting to do signing.
Less legwork as you go on.
Yeah.
Any other, yes?
First of all, thank you very much for the great presentation. And my question is, in terms of tools, what would you use to audit your security of the containers, like as part of the CI/CD pipeline? Are there any good open source tools available in the space?
Claire, the one he talked about earlier, is a Core OS tool. Have you used Claire? Or, it's easy enough with regards to, but then I mean, like, so you're looking at more of like CIS hardening. So it's like Docker Bench that has all the Docker like benchmark stuff. If you want to run something quick and dirty, run Docker Bench. It'll run through the Docker benchmark. There's a handful of other tools depending on what your orchestration flavor is, right, in terms of being able to audit those configurations. Yeah, and then there's the commercial tools, right? And I mean, I don't know, short of getting up here and promoting a commercial tool, check those out, right? There's, I mean, half a dozen at this point. If you've got money, someone's going to sell you software.
Thank you.
There's a Kubernetes benchmark.
It's actually fairly outdated now. They're still stuck on 1.8 on 1.2. So now we just released Kubernetes 1.11. So they're a little behind at this point. Yes.
Thank you for your presentation. And my question is, who have responsibility to make a second profile, ABAM profile against container? I think many containers have a different type of system calls, so capability. So I think developer doesn't have any knowledge about the system call. So.
Agreed. And so what he said is, if I correct, so things like AppArmor, SecComp are fairly hard for developers to digest, right? And to be perfectly honest, they're really hard for security people to digest too. Like, I worked with SC Linux for like a decade. I still don't know how that shit works. So me personally, I think it's very unfair to be like, hey, you're a developer, you have to learn SC Linux overnight. The defaults are there to just give you just enough, right? So if you look at how like the SecComp default works, they block all the dangerous syscalls up front. They give you a lot. I mean, there's a lot of syscalls. But they've at least gone through and cherry picked, like, here's what you really don't need. Here's what you really need to run containers, right? So are they all inclusive? Like, I mean, I'd say the SecComp one is, AppArmor, it's a little bit harder, right? So the default does some things, but as you know, AppArmor can be very complex. And depending on what's going on in your container. So there is some tuning if you want to make those really granular, but I don't necessarily know if that's your developers at that point doing that, right? That's going to be somebody, maybe on infrastructure, OS people, right? Most developers don't know the kernel.
You also want to be very careful about conflicting policies. So there is overlap, and so what you don't want is to have one enabling something and another disabling something, or the same thing.
We have to, ladies first.
So would you recommend actually just having like would you recommend having like a blessed image that has these defaults set?
Sure. So we talked about that a little bit in base image management. So you definitely should have base images that somebody's managing. So from a centralized repo, right? As opposed to everybody pulls down like the biggest Ubuntu image possible, and maybe it doesn't. So if you are controlling that and having a process, you do want to have base images that somebody is managing hardening, and then you can extend upon those, right? So yeah, that is a good way to go for sure. You shouldn't just let people pull down anything they want in any packages. You should have some group that's responsible for the management of that. Absolutely. Yes, sir.
Just a piece of advice maybe, you got to be careful what you're really editing, whether you're doing security with SecComp profiles, with capabilities, or with AppArmor. As you said, there's some overlap. You can shoot yourself easily in the
absolutely.
but you should also use one place. Docker, for example, the Docker container nowadays has 40 capabilities, and 14 are only allowed in a Docker container. For normal purposes, it's enough just to reduce the capabilities with, in my opinion, to reduce the capabilities and not to go in detail with SecComp, because there are like 300 syscalls there.
So they block all the really dangerous ones out of the gate, and then they give you the rest. So you can still reduce that more and drop more, but out of the gate, yeah. So one of the things he did mention, so AppArmor does a little bit of like syscall related stuff. So AppArmor is maybe a little bit more flexible. So you do want to be careful about like clobbering policies in one place and the other. So if you're doing those things in tandem, you definitely don't want to enable something at one and then kind of kill it somewhere else. So
If you want to learn a little bit more in detail about what went into those policies, Jessie Frizzell, she used to be on the Docker team, and she has a great blog if anybody wants to go out to it and take a look. Really great resources on explaining, because she was actually the one who created that Docker default policy for SecComp.
All right, let's give it up for Jack and Abdullah.